So we're going to look at how to do some of our quantitative uh, analysis in R. So last time we looked at uploading some data that was categorical, how to create some bar plots, Pareto plots, and pie plots. This time we're going to look at uploading data that is going to be quantitative, and we're going to be looking at calculating the mean, median, mode, standard deviations or variances, as well as doing a histogram and box plot. So in the tutorial 2, you can see that I have my tutorial 2.r script, which is the script that we're going to create today, paired up with the test underscore scores.csv. And we can, these test scores are going to be the test scores that are from our notes. So it's not going to be the same as what's in your assignments, but it's going to be close and it should help you with the assignments. So what I'm going to do is I'm going to copy this to help me read in my file. So I'm going to start by setting my directory to my source file location, and then I'm going to upload or read in a CSV file with the data. What I'm going to do is I'm actually going to do test scores. I'm going to have my name for my data, give a little bit of information on what it holds. So that's going to be read.csv. And now the file that it's going to be using, and this is where that copy helps. And if we go to that file, we can see, once again, we open it to see if it has a header or not. And we can see that it does have a header. So what that tells us is it tells us that header equals true. And then it's separated using a comma. And now, we separate. I'm going to tell it's equal to, and then it's equal to using the comma. And now we've got our test scores. So now that we've uploaded our test scores, it turns out that calculating the mean, median, mode, or mean, median, standard deviation, variance isn't that bad. So to calculate the mean, it's simply mean test score is going to be mean, and that's our test scores using those test scores. So our mean test score, we calculate by using this mean command. Now, notice what I'm doing with my naming. My first name is lowercase. Every name after that has the first letter capitalized. And this is a convention that is often used when creating variable names, is that if you have multiple words, the first word, or the starting is lowercase, and then every subsequent word, the first letter is capitalized. Then we have our calculating the variance, and our var of our test score is going to be var, and then it's test scores. And it's going to be our test scores. And then we've got our variance, and then we can also have something very similar for calculating the standard deviation. And short form for standard deviation is typically SD. And what you should note with calculating the standard deviation, which we do using the SD command, is that the way it calculates the standard deviation is always going to be a sample. This will always be a sample standard deviation where the mean is unknown. Okay. So it's always going to be assuming that it's a sample standard deviation and the mean is not known. So you're using the estimate of the mean when calculating the standard deviation. Now, so that's our mean, variance, and our test scores. The next thing that we're going to look at is the median. So calculating the median. Median test score. And it's just going to be median. And we input our test scores. And we've got our median. And now the last numerical summary that we'd like to have, we have our mean, our variance, our standard deviation, our median. The last one is the calculating the 5-number summary. To calculate the 5-number summary, test scores, we use 5num, and we simply input the test scores to give us our 5-number summary. And it gives us our 5-number summary with the 5 digits. So that is how we do the numerical summaries. And now, next thing we're going to show is we're going to show the histogram and followed by the box. So creating the histogram. So to create the histogram, it's simply hist, and we're going to put in our the first thing that we put in is the numerical values. And now the next thing that we're going to do is we're going to create our labels so that we can understand what the histogram is giving us. So if we just ran the histogram, it would give us this, and it's got these not so great titles. We'd like to change the x-axis title and the main title just to give a little bit more information. So to do that, what we're going to do is we're going to create our xlab is how we create our title for the x-axis. And that's what we're going to give the name test score. Right? And this is our label for the x-axis. And then our, we'd like to give a title, which again is going to be main. So this is going to be histogram of test scores. Right. Now if we run it, we get this. Oh, we did not put a comma in here. So when it ran it, it didn't like it. So now when we run it, it gives us our, you see that our title and our x-axis title have been updated. Now it only gives us 1, 2, 3, 4, 5, 6, 7, 8 breaks. Now, typically it'll give us a nice number of breaks, and picking that nice number is kind of an art, but R typically does a good job. If we'd like to change the number of breaks, we're going to use the breaks command. And if we have it at 8, you'll see it doesn't change at all. this is going to be the number of breaks. But if we change it to, let's see what happens when we change it to 10. If we change it to 10, you'll notice that it still doesn't change, which is kind of odd. But if we change it to 16, oh, what's going on here? Unaccepted symbol. Oh, we didn't put a comma. So let's try this again. So if we make it 8, we run it, it doesn't change. But if we make it 10, let's see what happens. It doesn't change. But wait, we gave it 8 and now it's 10. Why doesn't it change? Well, let's see what happens when we put 16. Oh, now it doubles. So what it wants to do is it wants to evenly break it up. So if it can't evenly break it up over the length, it's not going to break it up. It's going to round to a nice number that breaks it up evenly based on the range data. So if we give it 12, it still goes, okay, 16 is the best range. So we can't pick the exact number that it's going to have, but we can adjust how many breaks it's going to have slightly. Then R will say, okay, I know you want that number, but I'm going to pick a reasonable number that's close that is easier to use for creating these histograms. Okay. And then you know that we can save the image by right-clicking and clicking Save Image As. The last thing that we're going to talk about is we're going to talk about creating the box plot. So for creating the box plot, it's box plot, and we're going to put in our test scores. So the first entry that we put in is our numerical values. Once we've put in those numerical values, we can follow this up by our title. So main equals box plot of the test scores. And now we run it and we get our box plot. What is so lovely about R is a lot of these things that would take a long time to compute by hand, we can do very quickly using R. So while we've had you create these things using R in these two assignments, it would be very beneficial to know how to create a box plot and know how to create your histogram by hand, especially because they would be a great thing to test on, let's say, a midterm. Thank you so much and good luck with your assignment.